So far in this series, we have covered variables. We've covered control flow with like if and while and for loops, and we've covered some brief functions. So now let's use just what we've learned so far to make something very simple. And we're just going to make a very simple calculator. And so the goal here, all we're going to do is prompt the user for two numbers as well as what operation we're going to perform, and then we're going to perform that operation. Or if they give an invalid operation, we'll present an error. So I'm going to do this in C++. You can do it in any language, but instead of C, I'm going to do C++ just because input and output is just a little bit easier. But feel free to implement this yourself in whatever language you would like. So we're going to start with the way any good C++ application starts, and we're going to do pound import and IOStream. And basically what this does is we are importing, or no, it's pound include in C++. So IOStream is basically the input and output system for C++. Then we're going to do int main, and this is our input or this is our main function. So this is where control is going to start when this is executed. Now, so what we're going to do is we're going to prompt the user for two numbers and an operation. So we're going to go float a, and we'll just set it equal to 0.0 and b equals 0.0. So we're initializing two values, float a and float b. Now we're going to do std cout, and this is how we do output. And we're going to say, please enter a first number. And then we're just going to leave it there. And we're going to do cn a. Then we're going to do the same thing again. Cout, please enter a second number. Cn b. Okay, so what this is doing, so in C++, we have these namespaces, and so a namespace is basically like within a namespace you can have a certain function name. And so if you want to use just the standard library of C++, you just say, hey, I want to use the standard library, so it's std for standard. Then you do these double semicolons, and then what function or what thing you're calling in that library. A different way we could do that is we could say using namespace standard, and then we wouldn't have to do all that. I'm just going to leave it in though. So cout is print to the terminal, cn is read from the terminal. So what this is doing is it's going to print, please enter a first number, cn is going to read that number n, cout, please enter a second number, and I want to go capital there. And then we're going to read it into here. One more time, we're going to declare a char and operator. And we're just going to set that to, we'll just set it to empty space for now. And then we'll do cout, please enter an operation. Why is that complaining? Char. Oh. We'll just say op, because I think operator is a keyword. And then we'll tell the user what we want. So like plus, minus, multiply, or divide. And then one last time, cn, and then op. Okay. Now all we're going to do, just to test this out, we're going to do cout. We're going to do a, that, op, b equals, and then I'm just going to say to do. And then In order to have a new line character, we go like this with a /n, and that'll return to the new line. So all this is going to do is we're just reading in our first number, our second number, and our operation. Then we're just going to spit it right back out just to kind of make sure that all of this is working. So let's run this. Let's see. Okay, so it's doing all the compilation, and then let's see the debug console. Where's my actual terminal? There we go. Okay, terminal. So please enter a first number. Let's say 37. No, second number 42. Let's go plus. Okay, so 37 plus 42. Okay, so this is working as we expected so far. That's good news. Now, I'm going to drag this down. Now let's go back in here and actually make these functions. So each of these is taking in a float, so we're going to want it to return a float. So we're going to do 4 different functions: add, subtract, multiply, and divide. And each of them is going to return a float, so it's going to be float. And then we'll just do add float A, float B. Now, you can see that I'm using float A and float B, and I'm also using A and B down here. This doesn't have to be the same name. We could do X and Y. We can do whatever we want. They just have to be consistent in the actual function. So I'm going to do that for now. So let's go. All we have to do is, for add, we just do return A plus B. So this isn't a very worthwhile program because we already have an add function. It's right here. It's just the add. But this is just to get the idea of programming using functions and variables and control flow ingrained in your mind. So we're doing something very, very simple. So let's do float sub for subtract, float A, float B. Then we're just going to do return A minus B. Then our third function, we're going to do float. We'll do mult, float A, float B. Then we'll do return A times B. And then our last one, float div, float A, float B, return A divided by B. And we might want to check if B is 0 or not, because if it's 0, then we'd be dividing by 0, which is a mathematical error. So when you're programming, you sort of have to decide, where is error handling going to happen? Is it going to happen down here in the thing that calls the function, or is it going to happen in the function itself? So we could say, well, we just return 1 or something if it's a divide by 0. Or we could say, well, we're just going to expect that B is not 0 and leave the error handling up to whatever is down here. It's, different people have different ways of thinking about that. It's just kind of up to you. And whatever, if you're working in a big group of people, you're going to want to decide among, those people whose responsibility error handling is. And some languages are going to enforce it, that, oh, you have to handle the error in this spot or pass it up. In C++, though, that is not an enforced thing. Okay, so now we have our functions. Now we have to check somehow what we want to do. So the decision is on this value for op, whether it's one of these symbols. So if you think about, well, of the different concepts we've learned, which one should we use? Well, we can use conditionals like the if. So let's go down here and we'll say if op, and then we're going to do is equal to, so double equals plus. So basically, op is a single character. It's one character, even though the variable name is 2 characters. It stores literally just one character. So if op is equal to, this is the variable op, which is a character. As you can see, it's popping up and saying, oh, this is a character, which is just one byte value. So if that is equal to the character plus sign, here's what we're going to do. We're going to do std cout. We'll do add a, b, and then we'll do the new line character, and that's it. Okay, so now if we got an add, then this is going to say if op is add, if it's plus, then we're going to call the function add and pass it the values that we got. So before we go any further, let's just run that. All right, so it's compiling. Okay, so now let's use those same two values. It was 37, 42, and add. So 37 plus 42 is 79. So 7 plus 2 is 9, 3 plus 4 is 7. So that's good. That's exactly what we wanted. And we should go down here and do return 0 just to button everything up and say there were no errors. Okay, so what if it wasn't add though? Well, then we're going to use our control flow and say else if op equals, let's say, subtract. Then we're going to do this same sort of thing, except we're going to do sub, which is subtract. Easy enough. Then we can do this whole thing again and do else if op equals times, and we'll do mult. That's our multiply function. And then one more time, if it's divide, then let's go ahead and check our error here. So let's do another nested if. If b equals 0, then we're going to do cout error divide by 0 detected. So that's going to handle our error. Then we're going to do else, and if we highlight this and then hit our curly braces, it'll automatically surround that with curly braces. So else, it'll do standard cout, and we don't want sub, we want div. Okay, now let's test this out. So we're going to go ahead and run it. So let's do our same numbers, 37 and 42. I think that's what we used. And let's do minus. So 37 minus 42 is -5. Yeah, that's expected. So let's run it again. Let's see. Calc.exe. Whoops. exe. All right, so 37, 42, and we'll do times this time. So 37 times 42, that's a big number. Let's just make sure that that's right. I'm sure it is. 37 times 42, 1554. Okay, so two calculators agree, so hopefully that's right. And then let's go ahead and run it one more time. We'll do 37 and 42, and we'll do divide. And again, if we say, okay, is that right? 37 divided by 42. Okay, so it is, this calculator agrees, and it, of course, should be right. And let's run it one more time, and we'll say 37 divided by 0. And we'll say 37 divided by 0 equals error, divide by 0 detected. So then that way we are handling the error and making sure that the error doesn't actually happen. Now it's a little bit inconvenient to keep running this over and over and over, to have to like keep running the program just because we want to keep, you know, doing whatever. So maybe we can say at the very beginning, we'll do something like cout. Welcome to calculator. And then we'll do bool keep calculating, and we'll do true. Okay, and so we could do a while loop. Let's go ahead and do, though, a do, And then let's highlight all of this. And then we'll take all of this. And then we have to say while keep, what do we say? Keep calculating? Calculating. Okay, so now we've got our do while loop. Why is this throwing an error? Expected a declaration. Oh, yeah, that's what I thought. I have to go expected a declaration. I'm not sure what this problem is. Let's just do while keep calculating. Let's get rid of this. And then oh, that's what the problem is. Yeah, semicolon up there. All right, let's see if we can do this now. Do while keep calculating. I think we need a semicolon. There we go. Okay. So now we need some way of telling this, don't calculate anything anymore. So we can do cd cout, calculate another value. Yes, no. Okay. And then if, let's do stdcn, and then we'll do, let's see, we want to store this to another character. Let's just do it to op. So we'll do keep calculating is equal to, now this is an assignment instead of a comparison. So op equals yes, and then we'll do or, so this double pipe symbols is or, op equals yes. Okay, so remember from Boolean logic, if this is true or if this is true, and they can't both be true simultaneously, right? It can only either be uppercase or lowercase. It can't be both at the same time. But if one of these is true, then we will keep calculating. Otherwise, we'll just end. All right, so now let's run this again. Okay, so 37, whoops, 42, and then we'll do plus, calculate another value, we'll say sure, and then 5 and 8, and we'll do times, 5 times 8 is 40, yeah, that's good, and we'll just say no. Okay, and it's done. So now we have kind of a, very, very simple calculator that, when we first run it, it'll calculate 2 values, and then we could just keep working on this. And so you can see we've got functions, we've got our loop, we've got if statements, and this is just kind of the idea of when you're programming. You just keep building. You just think about, well, what's the next thing I need? Oh, I might have an error here. I need to handle it. Oh, I might need to do, I might want to keep going, so I should introduce a loop. And, now the next steps might be stuff like, well, what if instead of entering all this stuff individually, what if I just want to put the entire equation on a single line? Then you're going to have to read that line in, parse the line, figure out exactly what you want to do with it, store intermediate values as you kind of layer the different operations. And so, you just tackle each of those problems as you keep going. But this is kind of the general idea. So we're going to play with this concept a little more as we learn more about programming. We're going to just keep building on this calculator idea. And so we can introduce some newer concepts after this, and we'll use those further. But I hope this is helpful. You can kind of see how we can use what we've learned so far in this video series. So Thanks for watching, and I'll see you in the next one.